Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
Programming the Raspberry Pi Pico using the C language with the help of a Raspberry Pi. Let's get into it. Hi and welcome to RoboCraze. My name is Shiv and this video is the first in a series where I'll teach you how to program the Raspberry Pi Pico microcontroller using the C language with the help of a Raspberry Pi SBC. In this first video, we'll set up the SDK and have a look at the blink LED example. So to begin with, we first need to set up the Pico SDK on the Raspberry Pi. For this, I'm using a Raspberry Pi 3B Plus and I've connected power to it, and I have also opened it over here on VNC Viewer. Here you can see I've created a folder called Pico C tutorial in the home directory. You can go ahead and create a folder for yourself where you will be installing the SDK and putting all of your code in. Once this much is done, you can go ahead and open the Getting Started page. I'll leave a link to this in the description down below. Scroll down and click on Getting Started with C, C++. Here you can see there are a lot of UF2 files present, pre-built files for blinking an LED, printing hello world. But we don't need this. We first need to set up the SDK so that we can go ahead and write our own code and build it. So for this, scroll down to the SDK setup section and control click on the download setup script so that it opens in a new tab. Once it opens, just go ahead and copy the link, go back to your Raspberry Pi and write the command wget and then paste the link that you have just copied. Press enter and it will download the file for you. This Pico setup is a single file which will install the entire SDK and clone all the required repositories for you. We need to make it executable, so just execute the command chmod +x and then the name of the file. So what this will do is it will give execute permissions to the file. Then go ahead and write /Pico setup. With this, it'll execute the script and install all the required elements of the SDK for you. So just go ahead and press the enter key, and this will take a very long time to complete. You can wait until this is completed. And I'll join you back once the entire setup process is complete. Now that the setup is complete, it is asking us to run the command sudo reboot so that it can finish the UART setup. So I will go ahead and run the sudo reboot command to reboot the Raspberry Pi, and we'll just wait for it to connect back. Once it connects back, we will check whether or not the Pico SDK path environment variable has been set. If it has been set, then we are ready to go. And we can have a look at a couple of examples. Alright, so now the Pi has rebooted and it has connected back on VNC. I will open the terminal again and let us try to echo the value of the variable Pico SDK path. And as you can see, the Pico C tutorial SDK path has been set. So inside home Pi Pico C tutorial, this is the folder that I created. We have Pico and Pico SDK path. So let me just cd into this folder and see what all we have over here. So we have the Pico setup script that we used, and there is also a folder called Pico. Inside this, as you can see, we have all the repositories that we will need for this. You can see there is a Pico examples folder as well. Let us now cd into the Pico examples folder and see what we have. So if I just cd into the examples folder, we should have a whole bunch of examples over there, and we can have a look at the blink LED example. So as you can see over here, there are a lot of examples present, but we'll start with the blink example. So over here you can see that there is a blink.c file. Let us nano into it and see what is present. So they include the stdlib.h header file, and then there is the main function. Inside it, it just performs a small check to see if the default LED pin has been declared or not. After that, it declares a constant variable to hold the LED pin value, and we assign it as the Pico default LED pin. So this is the onboard LED of the Pico. The next line initializes the GPIO, and after that we set the direction as an output. This line is similar to Arduino when we say pin mode and your pin comma output. So it configures the pin as an output pin, and then we have an infinite while loop where we put the value of 1 onto the LED pin, give a delay of 250 milliseconds, and then turn the GPIO back off, and this should give us a blink effect. Now we need to build this code. So let us go back into the previous folder, the examples folder. There is already a build folder over here, and we can cd into it to see what's over there. After this, I'll also go over how to build it yourself. I'll delete the build folder, and then we'll try to build it ourselves. So as you can see, the same folders are present over here. I can go into Blink, and here you can see the blink.uf2 file is present. We need to upload these uf2 files to the Pico in order to execute our code. But let us try building it ourselves. I'll just go back into the examples folder, and I'll just try to forcefully delete this folder because it's not empty, so I can't use rmdir. So I'll just use a command that's a little bit stronger. But this is a very dangerous command, so be careful with it. I'm just deleting the build folder, and now let's create a blank folder called build. Now we cd into the build folder. These steps on how to build the code can also be found over here. I'll just close this as we don't need this anymore. There is this getting started with Raspberry Pi Pico documentation over here that you can look at. I'll give a link to this also in the description down below. But you can come to this section over here which says blinking an LED in C. The SDK setup is done for us, so we can skip point number 2. So we'll directly go to point number 3. Here is the code that we just looked at, and then it says how to build it. So it cds into the examples folder, creates a build directory, just as we did right now. You can see mkdir build. Then you cd into the build folder. So I'll just cd into the build folder now, and it asks us to export the Pico SDK path, but we don't really need to do this. It has already been done from the setup script that we had. So we're inside the build folder, and it should be empty. Next, what it says is to run the command cmake ... So let us run that command now. So the ls command returned empty because the folder is blank. cmake ... and we'll just give it a couple of seconds to build all the source files. After cmake is complete, let's just go over what the other commands are going to be while it runs in the background. So once the build is complete, it asks us to cd into the blink folder and run the make-j4 command. I'll just explain in a bit what that j4 signifies. So now cmake command is complete. If I do ls, you can see all the folders are now present in the build directory. I will now cd into the blink directory, and as you can see, the uf2 files are not here right now. That's because we have to run the command make j4. j4. Now I'll run this command and explain what j4 exactly does. This command is trying to build the output files, the uf2 files, and all the other files, all the other output files that might be required. j4 tells it to use all the 4 cores of the processor. So the Raspberry Pi has 4 cores, so I can run a j4 command so that it utilizes all the 4 cores of the Raspberry Pi. If your Raspberry Pi or whatever machine you're building on has only 2 cores or 1 core, you could run j2 or completely skip the j part itself. Just run make. Now that the command is complete, I'll ls, and now you can see the blink.uf2 file is now present. Let us now upload this onto our Pico. So what I'm going to do is, let me get this out of the frame for a bit. I have my micro USB cable over here. I am going to plug one end into the Raspberry Pi. And I'm going to keep this out of frame for now. The other end has to be plugged into the Pico. But to put the Pico into programming mode, I have to press and hold the boot cell button before I connect the cable. I can then connect the cable and leave the button. Now you will see on the screen, I'll get a prompt saying that a new device has been inserted, and what do I want to do with it. I can open it in File Manager, just so that we can see that it's connected. So there you can see RPi RP2, it has been connected. Now there are two ways of uploading your UF2 file to your Pico. I can either open the directory structure over here. I'll just give it a second to open. Alright, so we can go into the Pico C tutorial, Pico examples, build, blink. So if you remember, this is the directory where we had put our build files, and you can see there is blink.uf2. I can drag and drop this onto the Pico device, and it will reconnect, and now you see the LED is blinking. Let's try another way of doing this. So I'll just close the directory structure over here. You can do this using purely your terminal. You don't need to open the GUI, the Explorer GUI, so to say. So I'll just disconnect this, and I'll connect it in programming mode one more time. And this time when I get the prompt, I'll just cancel it because I don't really want to open it using the Explorer. So I'll just cancel it. The other way to do this is to use the copy command. So I can copy blink.uf2 to /media pi rpi rp2 and press enter. It will copy it, and as you can see, the device has been removed and our LED is blinking. So these are the two ways you can upload your code onto it. But now let us try making some changes to the Blink program to see if whatever changes we make are really taking effect and reflecting on the Pico or not. So for that, let us go back into the source directory. So I'll go up 2 levels, cd .. in Linux refers to the parent folder. So once it cds into the Pico examples folder, we can go into the Blink folder one more time, and I can simply nano into blink.c, and let us change the pattern a little bit. So what I'm going to do is I can say gpio underscore put led pin 1, and then I can again give it a delay of 250 milliseconds. I'm trying to blink it in a heartbeat fashion. So I can just say sleep underscore ms 250 over here, and I'll just fix the indentation there. And actually I can copy paste this because we'll be using this line one more time, these 2 lines. So I can simply copy it, paste it, and just increase the delay on the last one. Let's increase it to 500. 5 minutes should be good. I'll save it and close nano. I pressed Ctrl Z over there, which is not the right way to close it. You should press Ctrl X. Now I'll go back into the build folder, and inside the build folder, the Blink folder. And now we don't need to run cmake again. I can just run make j4 that is one more time, and it should update the file. Meanwhile, I'll just put the Pico into programming mode while the Pi is building the source. I'll just wait for the prompt to show up so that I can cancel it. There you go. Now cp blink.uf2 media pi rp2. I like using the terminal more because it's much faster than opening a GUI and copy pasting files. So I'll just press enter, it'll copy. And we are not quite getting a blink pattern because I have made a small mistake. This must be 0 so that it turns off in the end. So with that correction done, I'll go back into the blink folder inside the build directory and run my make command one more time. I'll put the Pico back into programming mode. And then the prompt will come up, which we can very promptly cancel. Copy blink.uf2 media pi rp2. So there you can see the effect is not as pronounced. You can go ahead and try to make the effect a bit more pronounced by playing around with the delay values a little bit, but this basically shows that our code is taking effect. So I can reduce all the other values and try to increase this a little bit, and the same way build blink make j4, and so this procedure is fairly fast. You can build your source fairly quickly and have it running on the Pico, sorry. We'll cancel this, go back to media rp2. Alright, so as you can see now the effect is a bit more pronounced. So that's all for this video guys. I hope you enjoyed it. I hope you learned something today, and if you did, do leave us a like and comment down below if you have any queries, suggestions or ideas that you may want to share with us. Don't forget to subscribe, because in the next video I'll go over creating a separate folder for our code instead of modifying existing examples, and then we'll have a look at a small button input function. So we'll take input from a button and print something on the screen. Until then, keep learning, keep programming, and I'll see you in the next one.